In this video, I will be reviewing the Unit 12 Equations Study Guide. So just as all of our other study guides, the first few examples are there if you'd like to review our work. This should be the same work that you have copied down into your notebook somewhere. So these are just other examples. Remember the rule, whatever you do to one side of an equation, you must do to the other side because it has an equal sign. So the first problems that we're looking at are modeling problems. And it says for number one, solve the equation represented by this model. So we need to use the key to get the equation so that we can actually solve it. So for this problem, I would have x, and then I have two negatives. So x minus 2 is equal to 1, 2, 3, 4, 5, 6 positives. So you could solve it mathematically. And I have this x minus 2, so I have to do the opposite, which would be plus 2 to both sides, because it's an equal, so I have to do whatever I do to one side, I have to do to the other. Remember, I'm canceling here, I'm undoing my work, so I'm left with x is equal to 8. The other way that you could have done this is with the modeling. So I know that these are negatives, and these ones are positives. So I have to undo the negatives with two positives. But whatever I do to one side, I have to do to the other side. So I have to give two positives here, but I can see that these are opposites, so they're going to zero pair out. So I'm just left with x is equal to all 8 of those positives. And again, you can check your work if you'd like, especially for these. Now, there are some that you're going to have to check your work. So you can put the box for x minus 2 should equal 6. And if you plug in 8, because that's what we said x was, is 8 minus 2 6? Yep-a-doodle, it is. All right, looking at the next one. So it says solve the equation represented by the model. So you could do it mathematically. There are two x's, so it would be 2x, and the bar is an equal sign. 1, 2, 3, 4, and they're all negatives. 1, 2, 3, 4 negatives, so negative 4. Mathematically, this is multiplication here, so I need to undo my multiplication. The inverse of multiplication, the opposite, would be to divide by 2, but because it's equal, I have to do it to both sides. So I'm left with x is equal to negative 4 divided by 2. Use that triangle. 4 divided by 2 gives me 2. A negative divided by a positive gives me a negative solution. So I have x equals negative 2. The other way you could check yourself is using the model. So I know that 2 x's are equal to 4 negatives. So what you could do is you could put one x and another x, and then split out the pieces. So I know 1 negative, 2, 3, and 4. So x would be equal to 2 negatives. Remember, again, you can also do that check step. So 2 times x should be negative 4. Well, if I plug in negative 2 there, is 2 times negative 2 negative 4? Yeah, it is. Okay, so you have different methods for solving those modeling ones. Scrolling down, looking at the next one, it says create a model to represent this equation. So we're just creating the model for this. So I have 4 x's, so I'm going to draw 4 bars. Is equal to 12. Well, 12 are the unshaded ones, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So that's 4 x's is equal to 12 positives. And again, I have to represent this one. So I know I have only one x, so I have x plus 4, so it'd be 4 positives, so they have to be shaded. See how they're positive? The shaded ones are positive. And that's equal to negative 6, and the negatives are the unshaded ones. So that's what this one would look like. All right, moving on to some solving ones. Solve and do a check step. So for this one, I have to try to get m by itself. I need to undo all my math to get m by itself. to figure out what does it equal. So I have m divided by 3. I need to do the opposite operation there. So the opposite would be multiply by 3. And because it's an equation and it's equal on both sides, I have to do it to both sides. These are going to cancel because they're opposites. And then you have to do 48 times 3. So I get m on this side because that's where it cancels. I need to figure out 48 times 3. I don't know that in my head, so I'm going to write it out. 8 times 3 is 24. 3 times 4 is 12. 13, 14, so 144. So 144 is equal to m. Now if I do the check step, I'm going to rewrite the problem exactly as it is. 48 equals, but I'm going to put a blank where the m should go, over 3. We said m was 144, so I'm going to plug that in here. And then I'm going to check, okay, well, what is 144 divided by 3? I know 3 goes into 14 4 times, which would be 12. Subtract, I get 2, bring down the 4. 3 goes into 24 8 times, perfectly. So I know that I got it right, because I got 48 here. But 144 would be the answer. All right, looking at the next one. I have x plus 31 is equal to 38, so I need to do the opposite operation there. I need to undo that addition, so I'm going to do subtraction with 31. This one cancels, like 0 pair out, so I get x is equal to, and then 38 minus 31 would be 7. Now I'm going to do a check step to make sure I got it right. Blank, which is the x, plus 31 should be equal to 38. Well, I know that x we said was equal to 7, so I'm going to plug in 7 here. And is 7 plus 31 38? Yep, it is. So we know that we got it right. All right, moving on to number 7. Number 7, I have 3 times x. I need to undo that multiplication, so I have to divide, and because it's an equation, it's equal, I have to do it on both sides. So these ones cancel, I'm left with x is equal to, now here's where it gets tricky, negative 18 divided by positive 3. Well, 18 divided by 3 is 6, and I'm going to have to use the triangle. A negative divided by a positive is equal to a negative solution, so I get negative 6. Let's do the check step to make sure we got it right. 3 times x, well, we need to fill in the blank, is equal to negative 18. We said that x was equal to negative 6, so I'm going to plug in negative 6 here. Is 3 times negative 6 negative 18? Yes, because 3 times 6 would be 18, and if you use the triangle, a positive times a negative gives me a negative solution. So I know I got that one right. Number 8 is probably the trickiest one on the whole page, and this is the ones where you need to do the multiplicative inverse, or kind of like our keep, switch, flip that we did for dividing fractions. Because this right here shows multiplication, and to undo multiplication you have to do division, and to do division with fractions you do keep, switch, erase. So we're going to do keep, switch to multiply, and then we're going to flip it over. So this is the piece that I'm going to multiply by on this side. So here this cancels, and I'm left with x. Now we have to use our fraction rules across the top and across the bottom. 10 times 5 is 50 over 1, which is really just 50. So I have x equals 50. Now let's check that. So I have 1/5. Why do I keep writing 1/2? 1/5 times that blank, which is x, should be equal to 10. Well, we said that x was equal to 50. Now, in order to take this fraction and multiply it by a whole number, 50 will have to go over 1. 1 times 50 would give me 50. 5 times 1 gives me 5. So 50 divided by 5 does give me 10. So I know that I got it right. That one is the trickiest one on this whole page. All right, scrolling down for number 9. This one says x divided by 6, so the inverse of divide by 6 would be multiply by 6 on both sides, so cancel here. Because they're opposites, I'm left with x is equal to 8 times 6 is 48. Now let's do our check. So I have x divided by 6 should equal 8. Well, we said that x was 48, so I'm going to plug it in here. And is 48 divided by 6? Yep, it is. All right, and then the last one, we have n plus 6, and I need to do the inverse there. So the inverse of plus 6 would be minus 6. 0 pair, so I'm left with n is equal to, now be careful, 3 minus 6. 3 minus 6 would be negative 3. I have 3 and I take 6 away. If you put positive 3, your check step's not going to be right. So if we do the check, if I just do 3 plus 6, that's not going to be 3. That's not going to work. So I know that that's going to be incorrect. Because remember, this is where x goes. This is our blank. This is x. So if we just put 3 in there, 3 plus 6 isn't 3. That's how you can check yourself and know that it's negative 3. Because if I'm at negative 3 on the number line, and I add 6, 1, 2, 3, 4, 5, 6, that's going to be negative 3, negative 2, negative 1. That's 0, 1, 2, 3. So that's how I know the answer should be 3. So make sure you're checking your signs especially so that you know you didn't make a mistake, and double check your check steps. Please let your teacher know if you're